Alright, hello students. We are now going to be looking at objective number 15 in this video, titled Writing Equations of Lines. Now this has typically been a very difficult objective for students, and so I'm going to try to show you multiple ways of approaching these types of problems. One way algebraically, the other way graphically. So let's look at problem number 5 here. Write the equation in slope-intercept form of the line that passes through the point 2, 4, and has a slope of 1/2. Now, the way that I would like you to do these problems is algebraically. Okay? That means using symbols and using equations and all of that. And the way that we learned to approach problems like this is using point-slope form. Okay? So there's multiple ways of writing the equation of a line, and one of them is point-slope form. And point-slope form looks like this. You take just any old generic y value minus y1, so a known y coordinate of a point on the line equals the slope times, in parentheses, any old generic x minus the x coordinate that is paired with that y coordinate. Okay, so a known coordinate on the line and the known slope, okay, will allow you to find any other y and x on the line. So that is point-slope form. So for question number 5, we are straight up given a point on the line and the slope. So it couldn't be easier to use point-slope form to tackle this type of problem. We just have to recognize that the slope is our m, 2 is our x-coordinate, and y is our y-coordinate. Okay? So literally all we have to do is just plug this information into point-slope form. So the y and the x are going to stay the same because we need a y and an x in the equation. We need to keep those the way they are. But the y1 and the x1, we're going to replace those. So y minus, our y1 is 4. So y minus 4 equals, the slope is 1/2, times, in parentheses, x stays the same, but we're going to replace x1 with 2. X minus 2. Okay? So there we go. We have successfully plugged all of the information we know into point-slope form. Now, the question asks us to write the equation in slope-intercept form, which is y equals mx plus b. Now, in order to get an equation into this form, we need to solve this for y. Now, there are 2 steps to solving an equation in point-slope form for y. The first step is to distribute. And by the way, I shouldn't have to tell you this, but you are writing all of this down. And the second step is to solve for y. I know that sounds kind of weird. Solve for y is the second step, and solving for y, you'll see what I mean in a second. So the first step is to distribute. So this slope here, distribute that into the parentheses. So y minus 4 equals 1/2 times x. Now 1/2 times a negative 2, if you need, you can use your calculator on that, but I hope it should be clear. 1/2 times a negative 2 is negative 1. Okay? So that was the first step, distribute the slope. And then the second step is to solve for y. Okay? And that just means move the 4 over to the other side. And we move the 4 by adding it. Okay? So, I'm running out of room over here. What we're left with is y equals 1/2 x. Negative 1 plus 4 is positive 3. Okay? That wasn't too bad at all. Notice this equation is now in slope-intercept form. The slope is 1/2. The y-intercept is 3. Now, I'm going to show you a different way of tackling the same problem, way that you might like a little bit better. Now, let us draw a real quick coordinate grid. Now, I highly encourage you, whenever you're approached with a problem like this, or whenever you approach a problem like this, graph everything you know. So we're given a point, 2, 4. Plot that. Over 2, up 4. Bam. Done. This is 2, 4. Now, it has a slope of 1 over 2. The line passing through that point has a slope of 1 over 2. That means the rise is 1, the run is 2. So from this point, we're going to rise 1, and we're going to run 2. Okay? So there we go. We have 2 points on our line. And in fact, we can continue this backwards. We can rise a -1, run a -2. Okay? So we can build our line that way as well. Ta-da! So here's our line. Now once you have a line plotted, you can use your skill in extracting what the equation of a line is from a graph in order to help you with this equation. So you're not just stuck in algebra land over here. Well, we know obviously that the slope is 1/2. Rise 1 over 2. And then look at this. The line crosses the y-axis at 1, 2, 3. Okay, so the y-intercept is +3. Now, just put this information into the slope-intercept form, which you should have tattooed to the back of your head by now. 1/2 times x plus 3 equals y. Okay, there we go. So if you can write an equation of a line from a graph, then you can do problems like this, as long as you find a way to graph it. Okay, and notice we get the same exact answer that we did over here. Okay, let's look at problem number 6. Write the equation in slope-intercept form of the line that passes through the point -2, 5 and has a slope of -3. Okay, so again, it looks like we're given the same exact pieces of information that we were up here. So we're going to do the same exact steps. This is x1, this is y1, and this is the slope. So go ahead and pause the video and try this problem on your own. It should be exactly the same as this. Did you really pause the video? Okay. So we're going to plug this information into slope-intercept form. So y minus the y1 is 5 equals the slope is -3 times in parentheses x minus x1 is -2. Uh-oh, we have to be really careful about that. X minus a -2. Keep that minus sign there because it's in the formula. So from here we're going to do y minus 5 equals -3. Whenever you have two negative signs right next to each other, they become a positive. Okay? Now, again, same steps up here. We're going to distribute the slope first. So y minus 5 equals -3 times x. -3 times 2 is -6. Okay? And now the final step is to add 5 to both sides. Okay? We're solving for y. We're getting y alone. So that means that y equals -3x. -6 plus 5 is -1. Bada bing. Y equals -3x minus 1. Now, again, let's do that graphically. Real quick coordinate grid. Now, the first point on our line is -2, 5. So -2 up 5. Bada bing. And then we have a slope of negative 3. So that means that starting at this point, negative 2, comma 5, starting from that point, our rise over run, our slope is negative 3. Now anytime I have just one number like that, I can think of it as being a rise of negative 3 divided by a run of 1. Okay? Because anything divided by 1 stays the same. Okay? I didn't change that number. It's just written as a fraction now. So if my rise is negative 3, I'm going to go down 3, and then I'm going to go over to the right 1. And then I'm going to plop down another point. That other point is on the line. And if you want, we can do a couple more of these. Rise negative 3, run 1. Hey, look at that. I just crossed the y-intercept. Sorry, I just crossed the y-axis, which means my y-intercept is that point right there. And I can do a couple more. And you get the idea. Okay? So here are the points on my line. And again, if you can successfully draw the graph of this line, you know that the slope is negative 3. That's going to multiply our x. Our y-intercept, you can clearly see, is negative 1. And that is exactly the same answer that we got algebraically. Okay? So these two skills are not, they don't exist in a vacuum. All of this is interrelated, and however you want to approach the problem, feel free to do it, however you want. Now, let's try this problem. Write the equation in slope-intercept form of the line that passes through the points negative 1, negative 5, and 1, negative 2. Okay, so this problem is a little bit trickier now. Instead of being given a point and a slope, we're given 2 points. So we have to find the slope ourselves. So let's use the slope formula. M equals y2 minus y1 divided by x2 minus x1. So let's identify what our stuff are. So the negative 1 is x1, y1, x2, y2. Okay? So let's just plug this information in. And we have to be very, very careful about our negative signs, because we have lots of them. And these negative signs are going to interfere with the minus signs that we already have. So this is going to be equal to y2 is negative 2 minus y1 is negative 5. x2 is 1 minus x1 is negative 1. Ooh, look at that. We have minus signs right next to each other. So we have to cancel those out. Negative 2 plus 5 divided by 1 plus 1 is equal to negative 2 plus 5 is positive 3 divided by 1 plus 1 is positive 2. Okay? So there's our slope. But we're not done yet. We have a slope. Now we have to plug this slope and either one of these points. It doesn't matter, but we'll do the first one. Plug this slope and this point into point-slope form, exactly as we did up here and here. So I'm just going to write down what point-slope form is again. You should have this tattooed to the back of your brain by now. Now, y stays the same, minus y1 is negative 5. Our slope, we now know, is 3 over 2. X stays the same, but x1 is negative 1. So we're going to have x minus a negative 1. X minus a negative 1. Don't you just hate these negative signs? Ugh. Now, let's write this line again, except we're going to clear out all those minus signs. Y plus 5 equals 3 over 2 times x plus 1 Okay, so now that's cleaned up a bit. Now we're going to distribute the 3 over 2, just like we did up here. We distributed the slope, we distributed the slope. Y plus 5 equals 3 over 2 times x plus 3 over 2 times 1 is just 3 over 2. Okay, and now here's the final step, is to subtract 5, to move it to the other side. Okay, so this is kind of an ugly mess right here. Let me show you what we've got. We have y equals, okay, 3 over 2x. And then down here we have 3 over 2 minus 5. Now we learned how to combine, or to deal with fractions whenever we're adding them or subtracting them or whatever else. But I don't really want to deal with that here. Get my light out of the way. Let's just do 3 divided by 2 minus 5, negative 7 over 2. Okay, so negative 7 over 2. Ta-da! That is it. Y equals 3 over 2x minus 7 over 2. Okay? Now, I promise that you can do this graphically. Actually, yeah, let's go ahead and do it graphically as well. Okay, just to check to see that we got the correct answer. So, I'm going to get a new grid paper. Oh, that's not new. There we go. So, I'm going to draw a real quick coordinate grid. So, our first point is negative 1, negative 5. So, left 1, up, wait, negative 1, negative 5 means left 1, down 5. So here is negative 1, negative 5. And then the next point is 1, comma, negative 2. So over 1 to the right, down 2. Bada bing. So we have our 2 points, and you can clearly see, once we graph the 2 points, you can clearly see that the slope is rise 3, run 2. Rise over run, 3 over 2. You can clearly see that. And you tell me, which is easier? Graphing it to find the slope, or doing all this mess? Yeah. So just do whichever one you're comfortable with. In fact, do both, just as a way to double check yourself. Okay? Because you should always get the same answer. And if you don't, really, I would trust your graphing over this mess. So our slope is clearly 3 over 2. And if we were to draw a line, you can see that our line appears to cross the y-axis right about here. So it crosses in between 2 grid points. And actually, let's take negative 7 over 2 and let's convert it into a decimal, negative 3.5. And look at that. 1, 2, 3.5. So it appears that our y-intercept, negative 7 over 2, which is the same thing as negative 3.5, it appears to match what we've graphed right here. Okay? Alright, that wasn't too bad at all. We just double-checked ourselves. Okay?